Hey guys, welcome to yet another flowchart task. This one I'm going to continue with where we left off. Okay, now that you have gotten the decision or conditional icon or image, which is called diamond shape. Now, if the input of the user is not valid, so it should end the program. But if it is valid, then the program should continue. Now if the program continue, then here is where we are going to perform the operation in terms of finding the sum of square root of the numbers that the user entered here. Now for us to get the icon or the image for it, we need to go to this our general tab here and select rectangle. Remember, I said rectangles are used for process, action, steps, or operations. So we need to perform some operations on this data that was given to us. So we are going to use this rectangle. Let me position it. Okay, so let's color it. I'll color it this orange. Now what we are going to tell this, the operation that is going to perform is going to perform about four operations or three operations. Now one is that it's going to get the remainder of the value. Two is that it's going to sum the remainder times itself, the remainder itself. Then the third one that is going to divide the number divided by 10. That will give you the sum of the number, or that will give you the solution. But let us just code it. Along the way, if there is any modification, you will see it. So let's call our remainder. We are going to use R. Okay, let's use R, just R, to identify our remainder. Then we now say X copy. So the modulus sign is used to find the remainder of a number. Okay, when you divide 2 by 5 by 2, is going to be like 2 remainder. You get the remainder is used. This modulus, this dollar sign is called modulus, okay, or modulus, anyhow you wish to pronounce it, is used to find the remainder of any given number. So when you have done it, let's reduce the font size. Let's reduce the font size. Control A to highlight. Then let's reduce it to, okay, 17 is okay, because we need to type more things in here. So the next one is we need to define our sum, the variable that is going to hold the sum of the numbers that we are going to compute. Now the sum is going to be, the code for it is going to be sum equals to sum plus the remainder, which is this R, times R. So this R is timesing itself, multiplying itself, then adding the sum, adding the result of itself multiplication to the sum. Okay, so that is that line. Okay, so having written this code here, now remember a square is 4 equal parts. That means the breadth and the length, or the breadth and the length. So that means you are timesing the breadth and the length together, and then summing it up, giving it to sum to hold. So that is what this code here does. You are timesing the breadth and the width, the the breadth and the length of a square. Okay, you are timesing them together, and it must be in a while loop. So it's going to be in a while loop, in terms of it's going to loop. So before we do this sum, before we put this sum here, we need to enclose it in a while loop. So while the number, which is this copy x, x copy, I meant to say x copy, I cannot even type correctly, x copy, okay, is greater than 0. Okay, while this x copy is greater than 0, what next do you want to do? You want to perform this operation. So each of this remainder will be timesing itself, and adding it with sum, and sum will be summing it to itself. So this sum and this sum are the same thing. So there is a methodology in programming that allows this to be correct. So if you want to know how this sum and this sum are here, okay, you have to go and read, further read about it. But this syntax is correct. So it loops through the x copy. That means the 1 2 3 that you have entered here, either 1 2 3 or whatever you have entered here, it loops through it, and then times each of the loop. For example, if you enter 1 2 3 here, enter 1 2 3 here, so it loops this one the first time, okay, times 1 times 1 plus sum is 0. Okay, at the first initial running of this program, this form is null, which is 0. Okay, when it loops through this this s copy, which is this what you have typed here, which we initialized it here, so it will loop at 1 will be times by itself, which is 1 times 1 is 1, plus sum, which is 0 plus 1. Do you get? So it's going to be 1, right? Now it now loop again, 2 times 2 is going to be 4. Now remember that this sum is now 1 because it has already gotten 1 from here. Okay, now this sum is 1. Now 2 times 2 is 4, plus 1 that is here, which is 5. Now this sum here, now this sum and this sum will now hold 5. Now it will now go to 3. 3 times 3 is 9. Yes, 9 plus 5 is 14. Do you get? So this sum now will now be 14. Now it now go to 4, and get 4 times 4 is what you call 16. So 16 plus 4 times 4, is it 16? I cannot even time self. 4 times 4, yeah, 16. So 16 plus 14, which is 30. So the sum of the square of this input is 30. So our form right now, or our result right now, is 30, which is the answer to this question right here now. So let me okay, now after doing this, you need to print out the results. Okay, now we have this icon, this parallelogram, okay, to print out the result. But before you add this parallelogram, you need to add your what is it called, your arrow, your directional connector, okay, to connect this particular program to this program. Okay, it shows the flow. You can see it went up here, shows the flow of the program, down here shows the flow of the program, down here. So if the program is not correct, it goes to this guy here, this end, the program will end. But if it's correct, it continue going down. Okay, so the arrow shows the flow of our program. Let's turn this arrow. I don't like bringing these icons without bringing the arrow first. Okay, let's turn it. Okay, now this parallelogram is used to input and is also used to output. Okay, it does two things. Right here we used it to input something, but down here we are using it to output something. Okay, so you have to know the different operations that all these things does. Okay, so down here now, let's give it a color of, which color are we giving it? Why am I even concerned with colors? Let me okay, let's give it brown. Okay, now you double click on this, then you now say print sum. Now this prints out the sum for you. Okay, so I think after this, the next one that we are going to do is to end the program, just as we end here. But here is a false. When we encountered an error, it ends here. But when we don't encounter an error, okay, it should end somewhere here down there. Okay, now for you to continue, there's something they call off page. For you to connect one page to the other, there's something we call off page, and I can't see it here. Let me go to advanced. This is the off page here. You can see the off page connector. So as you can see now, my this worksheet here is filled up. Okay, I even have space here. I'm not gonna even do this. Okay, let's try to highlight this and drag them up so that you can have room. Oh no, highlight everything, drag up. Okay, we now have room for our last diagram. Now the last diagram is going to be the print and the end of the program, because we have achieved our aim. Okay, so let's bring up this eclipse. Oh, before bringing the eclipse, let me bring this directional connector, then bring it down here, rotate it so that it will point to the direction I want it here. Okay, so let me minimize this. Okay, so I bring the eclipse and position it. Now I'm going to color this eclipse green because our program runs successfully. Okay, so I now say stop to stop the program, and that is the end of the flowchart. Okay, so this is a complete working solution for flowchart. Let me recap. You start the program, you allow the user to enter numbers or to enter an integer that they want to find the square of the sum. Then when this allows when the user enters the number, now the number is being saved inside this X copy. Now after that, you have to check the input, that is the number, whether it's valid or not. If it is not valid, your program will end. Or you can actually tell your program to ask the user to enter a valid input. okay, but for the simplicity of this task, just end the program. So but if the value is valid, that if it is less greater than 0, okay, so it will, that means it is true, our program will start running. So now there are 3 steps here. First of all is you define a remainder of the data that was imputed here. Now by using this line of code, okay, so this s copy has the value of your data. This mod percentage sign is the modulus, okay. The remainder, it finds the remainder for you. Then this 10 is what you are trying to divide it with, okay. Now this loops the s copy for you. It loops the s copy data. For instance, if you have 1 2 3 4, okay, as the value that you imputed up here, then this will loop. First of all, it will loop the first number, which is 1. After that, it will loop the second one, it will loop the third one, it will loop the fourth one. You get, depending on how many numbers that you imputed. Now when this sorry, when this is imputing, as it's looping, it is summing itself. It is summing itself and multiplying itself. Okay, so if you need more explanation on this, just hit me up on the comments box below. Now when everything is done fine, all the data will be stored here, which is the square sum of the value that you imputed here will be stored here. Now the program will continue down. You now print it to the screen for people to see. Okay, after that, there's no more task for your program to do. That is when you now end the program. So with this, I think you are done with the task, the flowchart task. Now upcoming video is going to be the pseudo code. Okay, we are going to transform this picture into text, into English like text. Okay, so stay tuned for that. Thanks for watching, and please don't forget to subscribe, okay, and turn on your notification button.